Hi, while we're on the radios, I'm putting up a Perdio. Get the name. This was a British made set of the late 50s, early 60s. It was a very nice set. It had long, medium and short wave. Made out of wood. You can get an idea of the size. I'm holding the handle. There's your dial. You've got your long wave light on the long wave, and the short wave on the outside, and the medium wave, or the broadcast band if you like, on the outside. It's one that I got to restore or try and get it working. As you can see, it's missing, the knob down there is missing its trim. So it's a case of looking round. You never know, one could turn up. Well, in fact, there is another of these sets which I've got, and that's being put in the post tomorrow, and that has got the other button. So between the two of them, I should be able to get a nice set. Now, I remember these sets when I was quite young. There was an office where my father worked at, and the night watchman was given one of these, or given it to it. It was what he used during the night to make life easier, and I was astounded at the actual quality of the sound. Now, once again, there's no sound on this yet because I haven't got that far, so this will probably be put into a second part when I get it going. I've no idea whether it's going to work, but let's have a look at the back. I'd say the back is always the interesting bits. I'll lean it over. There we go. You've got your ferrite rod with your 3 cores for your bands. You've got trimmer capacitors. These are, I'll get it closer, they're variable capacitor. You've got 2 brass plates, between them is a strip of mica, and by screwing them down, making them tighter, you alter the value of them, and they're used as trimmers. They're connected to the aerial, and that is all comes into the alignment. You just peek up on these things. I've looked at them, they don't look like they've been tampered with in any way. The cores are all okay. You can see so much by just looking. As I say, you get something on eBay, you really don't know what you're getting, but this was shown as a photograph, and careful looking at it, you can get a fairly good idea whether it's been hacked about. This one hasn't. At the bottom there is your wafer switch. That comes into play with your 3 bands, depending on what position it's on to what band you're going to receive. Looking at the speaker, what is noticeable about it is the size. Good size. There's my hand, so it gives you an idea the other speaker size. It's manufactured by one of our well-known speaker manufacturers, so much so I've forgotten the blooming name. Goodman's. Let's have a look. Wembley. The name's round the outside. Yeah, it's Goodman Industries Wembley. They were famous loudspeaker makers. The Goodman's name is now used on radios and things, but I think someone else has actually bought the name. But in the times this was made, they were a well-known firm, and they did make some good loudspeakers. Leaving the loudspeakers, you've got your two sets of leads that would plug into a battery. The batteries, it uses two batteries, 4.5 volts each, and they're split. Now that means that, having a look at the diagram, get it in, I don't want to bleach it out, so I'll turn the light away. There's your diagram. They're the two batteries, 4.5 volts, through your on-off switch, which is on the volume control. It's centre tapped, so you have to use two batteries. You can't sort of short one out and say, right, I'll just put 9 volts, 9 volts across it. That won't work. It's actually split and it's balanced. And this coil there, which we can see, represents the loudspeaker coil. It's being fed from these two transistors, which are a matched pair, which means they're identical in every way, and that provides what's known as a push-pull output. Your driver transformer's there, and the driver transistor. This part here is for amplifying the sound, and as I say, it's push-pull, so this is why, or one of the reasons why, the batteries are actually split in two. So you've got an even power supply on both cycles. It's nice, huh? Very, very simple diagram. In those days they didn't mind people opening up the sets, and if a transistor blew or something like that, or a capacitor went down, you would do it yourself. Not like today. These represent the intermediate frequency transformers. More transistors. That would be the oscillator coil. As I say, these all work on the other super heterodyne principle, which I mentioned on other videos I put up, and the poor gentleman that chucked himself out of the window. These coils are the coils which you see on the ferrite rod. It has got an external aerial which is in there, and that was for use if you were taking it out in the car. As I mentioned also before, in those days not all cars had radios fitted, so you would take your portable out with you. When you were in the car, you would plug in the aerial that was out, the car aerial, plug it in, and away you went. The batteries would fit in the space there. You've got space there where the batteries would fit in. So 4.5 volts each side. I will be making a set of NiCads up to replace them, and we'll fit them in there somehow. Components at the back are two large capacitors. There's more capacitors. TCC is the telegraph condenser company. They were still going there. This wax one is Jubilia, which is also a capacitor manufacturer, and that's actually called a capacitor. In the old days they were called condensers, but the name did change. That's your volume control, and your transistors are these things. Those pink things are the transistors. That's the matched pair. You've got the driver down. You've actually got a mixture of GEC transistors and Mullard transistors. They're the Mullard, the OC71s, 81s, OC44s, I think are those ones. I remember that from years ago. I mentioned the transformer, didn't I? Yeah, I showed that. Yeah, that's the transformer. Anyhow, that's about all for this one. If I get it going, and when I get it going, I'll put a video up, and hopefully I'll be able to give you an idea of the sound, because these sets did have quite a nice bit of volume, and being in a wooden case, that really helped. Anyhow, once again, many thanks for looking. Any comments please make. I'll try to answer them. I'm not saying I'm going to answer them, but I shall certainly try to. This just shows down here the transistors that were used. OC44s, it gives you the equivalent ones, your diodes. Also, the different numbers of the batteries being used. You've got Drydex, Eveready, GEC, Siemens, Vidor. Now you'd have a job to find many of those names. I know Eveready are going still. I don't know about Vidor, but the other ones, as far as I know, are not still going. So that is it, and it also gives you all your different values, resistors, capacitors. So if anything goes wrong, it's all laid out, made nice and easy. You've got your test points there for your voltages when you're aligning it. It even tells you how to remove the actual chassis. Anyhow, once again for watching. Any comments, as I say, please make, and thank you again. Thank you.